So in this lecture we would be solving some problems related to functions. So let's quickly start. So our first problem for today is, so we are given a function, so we are asked to find the domain. So it's x square plus 3x plus 5 divided by x square minus 5x plus 4. So this is our function. So here we have numerator here and denominator here. So it's a rational function, and in rational function we see that this denominator should not be equal to 0, otherwise this function would not be defined. So here x square minus 5x plus 4 should not be equal to 0. So this is x square so we will solve this equation, and so if we take x minus 4 times x minus 1, this would be equal to this x square minus 5x plus 4. So here the trick is to break 4 into two factors such that their sum is equal to this 5. So if it would have been plus 5, you would have taken x plus 4 multiplied by x plus 1. So break 4 into two parts such that their sum is equal to this here 5. So 4 and 1, its product is 4 and its sum is 5. So this should not be equal to 0. So if any one of these is 0, then the whole term becomes 0. So individually both these terms, so none of these can be 0. So x minus 4, this cannot be 0, because if this is 0 then the whole term will become 0, and x minus 1 should also not be equal to 0. Or in other words, x should not be equal to 4. So we have just moved 4 to the other side, and from this equation x should not be equal to 1. 1, yeah. Or in other words, x should not belong to the set containing 1 and 4. So the domain we can write as the set of real numbers minus the set of 1 and 4. So this is our answer. So the only thing we have to take care is that this denominator term should not be equal to 0. So if x is 1, if we put 1 here, then this becomes 1 minus 5. For 1 it will become 1 minus 5 plus 4, which will be 0. And for 4 it will become 16 minus 20 plus 4. So x should not take the value of 1 or 4, otherwise all the other real numbers are fine. So this is the domain of this function fx. So we will see our next problem. So it says let f is equal to, so here we are given f as the ordered pair, so 1 1. So the first term is x and the second term is fx, the value that we get by putting x in the function f. So 1 1 2 3 0 minus 1 minus 1 minus 3. So this is our function f, and it said that it is linear function from capital Z to capital Z. So Z is the set of integers. So it's not written whether it's positive integer or negative integer, the complete set of integers. So we are asked to find fx. So in last class we had seen linear functions. So linear functions fx, these take the form of mx plus c, where both m and c are constants. So so we can write linear functions are of the form this, and then we will substitute the values that we are given here. We are given x and fx, the pairs of x and fx, x and fx. Substituting the values of f for various values of x, we get, what do we get? We will take the first point 1 1. So first we will substitute 1 1. Then we will get 1 is equal to, so here at the place of x we will substitute this 1, and this second one is fx. So this 1 is fx in the LHS, and in the RHS it will be m times 1 or simply m. So this is our one equation. So m plus c is 1, we got one equation. Now we will substitute, or we can put it in the same line with, and next we can substitute, let's take this 0 minus 1. We could have taken second point also, 0 minus 1. So here f is 1 and x is 0. So this mx will become 0 because x is 0. So it will become 0 plus c. Sorry, here fx is minus 1, not 1. So this will be minus 1. So minus 1 is equal to 0 plus c. So x is 0, so this term becomes 0, mx becomes 0. So this is our second equation. So clearly from second equation we got the value of c. From equation 2, c plus 0 is equal to minus 1, or c is equal to minus 1. So we got the value of c. So we will substitute this. So here we have got the value of c. C is minus 1. So we can put this in our first equation. Substituting the value of c in equation 1. What do we get? 1 is equal to m and in the place of c minus 1, or m minus 1 is equal to 1. We will move 1 to the other side. M is equal to 1 plus 1 is equal to 2. So we got the value of m also. So if we know the values of m and c, then we know the equation of this straight line or this linear function. So f x is equal to mx plus c, or fx is equal to 2x. In the place of m we put 2, and in the place of c we will put minus 1. So 2x minus 1. So this is our function. So to find the equation of a linear function, we just need 2 points. If we join any 2 points in a plane, we can form a straight line. It doesn't matter how many points we are given. We just need 2 points to form a straight line. So this is our equation of a straight line or this linear function. So that's the solution for second question. So now we will see third question. So it says the relation f is defined as fx equal to x square when x is between 0 and 3, including 3. X can also take the value of 3, less than equal to 3 and greater than equal to 0, and equal to 3x. So this is x square when x is between 3 and 10. So again including 3. So this is the function. This is the relation, not function. So this is the relation we are given. Fx is this. and relation G. So we have another relation G, x square when x is between 0 and 2, and 3x for less than equal to 10. So we have to show that x is a function. The relation defined by f defines a function, but the relation defined by g does not define a function. So for a function, we remember we saw that for every element in a domain, so if a relation is defined from A to B, then for every element in A, there should be one and only one image in set B. So it may be that more than one element of A has the same image, but it cannot happen that. So it cannot happen like this. So it has one element here, so it cannot have two images. So this is not allowed, but this is allowed. So every element in A should have one image in set B. But one element cannot have two images. So in other words, uh, some element A cannot be the first element of the ordered pairs defined by A, by function or relation. So this cannot happen, that AB and AC are ordered pairs within a function. So then this relation is not a function. So here we will see. So for f, if x is 0, this will be 0. So for 0 we get 0. If x is 1, we get 1. If x is 2, x lies in this range, so it will be defined. So this function is defined from 0 to 10, only 0 to 10, not any other element. So for 0 it takes the value of 0 because x is between 0 and 3, so we will take x square. So 3x comes only when x becomes equal to 3 or more than 3 and less than equal to 10. So for 2 it will again be x square, which is 4. For 3, so 3 is included in this range. So x is less than equal to 3. So from this formula x square, it should take, so this is x and this is f. So it will be 9. But and now if 3 is more than x is more than 3, then this we will take this range, this formula. But here also 3 is included in this range. So for 3, it should be 3 times 3, 9. For 4 again 12. So we see that for 3 using both the formula x square and 3x, we get the same value of f, that is 9. So uh, so this is redundant. So 3 is just mapped to 9, single element, and all the other elements will also be mapped to one element. It's not that 3 is taking two values. Now if we take the case of g, so x and then gx, 0 1 2 3. So here for 0 1 2 it should be x square. So 0 1 square is 1, 2 square is 4, because 2 is included in this set, less than equal to 2, but 2 is also included here. So for 2 using this formula we get 6, and for 3, now 3 is more than 2, so it will be defined using this, 9 4 12. So all other elements will have just one image, but we see that for 2 we get 4 and we also get 6. So this is the culprit here. So here 2 has two images. So if this is x and this is g, then here it's 4 and it's also mapped to 6. So this 2 has two values defined by g. So this is not a function, but this is a function because every element had single value. 2 has 4, 3 has 9. Using both x square and 3x we get 9 only. So 3 had one value. So in this way we can say that g is not a function. We can write that for a relation to be a function, every for a function for a relation from set A to B to be a function, every element in A should have one and only one element in B, image in B. And now we can write the images. We can write the ordered pairs. So f is equal to, so f is defined from 0 to 10. So we will write all the ordered pairs, 0 0 0, then 1 1, then 2 4, then 3 9, and when x becomes more than 3 we will use 3x. More than 3 or equal to 3. So again 3 9, then 4 12, then 5 15, all the way up to 10 30. So here this 3939 is repeated twice, so we generally don't repeat ordered pair, same ordered pair multiple times, so we will get rid of this, and then we will write g. So it will again be 0 0 1 1, 2 4, and when x is equal to 2, so it comes under this category also and this range also, both ranges. So 1x square we have written 2 4, and another is 3x, so 3 times 2 is 6, so 2 6, then 3 9, 4 12, all the way up to 1030. So here the first element of each ordered pair is different. It cannot be repeated in two ordered pairs. So here 0 1 2 3 4 5, all the first elements are distinct, but here we have 0, we have 1, we have 2, and again we have 2, so here 2 is repeated. So we will write in F the first elements corresponding to all the ordered pairs are distinct. So F is a function. But in G, element 2 appears as first element in two ordered pairs. Namely 2 4 and 2 6. So 2 has two images defined under relation G. So G is not a function. So we have to write the actual ordered pairs defined by F and G, and then we see that if all the first elements are distinct, then it's a function, and if all the ordered pairs defined by a relation, the first elements are not distinct, it's repeated, then we can say that it's not a function, and we can diagrammatically explain it using this, but this is not required. This was just for understanding purpose. So now we will see the fourth example. So this is fx is under root of x minus 1. So this is our function. We are asked to find the domain and range. So domain, if for this value under square root, this should be greater than equal to 0, because this is a real function. So here the term real is important. Real means that the function takes its domain is real as well as it gives real valued output. So if this term here becomes less than 0, then we will get imaginary numbers, not real numbers. So we will study about imaginary number when we study complex numbers. So so the value under this square root term should be greater than 0, greater than or equal to 0. So we are finding the domain. So for domain we need x minus 1 greater than equal to 0 or x greater than equal to 1. So it can be 1, 1.5, 3, 4, 5, anything. So its domain would be, so when we write this square braces, it means including 1, and with infinity we always use this curly braces, small braces. It means not including this. With infinity we will always use this because infinity is never included, and this square bracket means 1 is included. So starting from 1 till infinity, but not less than 1. If it becomes 0.5, then this term will become minus 0.5 and its square root will not be real, it will be imaginary. So this is the domain, and what would be range? So if x can take values 1, so x can take only values from this onwards, 1 onwards, not this side. So at 1 this will be exactly 0 because 1 minus 1 becomes 0. At 1.5 or let's say 2, it will become square root of 2 minus 1 or a square root of 1, which is 1. So at 2 it will become 1. At 3 it will become root 2. Root 2 is slightly more than 1. It's 1.4. So somewhere here. For 4 root 3 1.732. For 5 it will become 2. So it will be a curve like this kind of curve. So its range, it can never be negative. So its minimum value would be 0, and for infinite it would obviously under root of infinite would be infinite. So its range would be 0 to infinity. 0 when x is 1, and it will gradually increase as x increases because this x minus 1 increases when x increases. So this would be the domain and range. So this was our fourth example. We will take fifth example. So f be the subset of z cross z defined by f is equal to AB. AB is the first element of the ordered pairs and A plus B is the second element, such that AB belong to Z. So A, B are integers, and if we pick any two integers A and B, we will form an ordered pair AB, and the second element would be A plus B. So we are asked, is f a function? So this is the question. So we are given a relation which is defined by this. So it's in the set builder form. So let's pick two integers, say 3 and 2. A is 3, B is 2. So these are AB, and here we get AB and A plus B. So if A is 3, B is 2, we get AB as 6 and A plus B as 5. If we just flip AB, then we get 2, 3 again, 6 and 5, no problems. But let's take negative of these. We know that negative x times negative x will become plus x square. So if we multiply two negative numbers, we will get positive number. So if we take minus 3 and minus 2, so minus 3 and minus 2 also come under this z. So this can be any integer, positive or negative. So again, minus 3 times minus 2 is 6, and their sum is minus 5. We can also take any other factor of 6. Let's say 6 and 1. Then again their product is 6, but 6 plus 1 is 7. And similarly minus 6 and minus 1, their product is again 6 and their sum is minus 7. So we can have many more examples. So here we see that if 6 is in the domain, then 6 is, so this AB is the first element of the ordered pair and A plus B is the second element. So this AB 6 is mapped to 5, 6 is also mapped to minus 5, 6 is also mapped to 7 and minus 7. So first we can write some general statement like uh, if we take any two integers A and B, so A and B will belong to Z, then AB, A plus B forms an ordered pair of relation defined by F. If we take integers minus A and minus B belonging to the set of integers, then minus A times minus B is AB and minus A minus B forms an ordered pair of relation defined by F. So this is the general statement. So if A and B, we pick any two integers A and B, then AB and A minus B AB and A plus B forms an ordered pair, and for different integers minus A and minus B, again AB forms. So here AB is the first element of both the ordered pairs. So we saw that for 6 at least we have two images, but we can have many other factors of 6. If we have a larger number, we will get many more images of that element depending on the number of uh, factors in which we break 6. So we can write that. So here AB has A plus B as one image and minus A minus B as another image. At least two. We don't know there are more, but at least we have two. So at least for two ordered pairs in F, AB is the first element. So so the relation defined by F is not a function. So this should be enough, but it's always good to give an example. So after writing this statement, we can also write, for example, 6 and 6 5 and 6 minus 5, 6 5 and 6 minus 5 are ordered pairs corresponding to integers 3 2 and minus 3 minus 2. So we can elaborate more, but this should be fine to explain the answer. It's always good to give some example. And now we will take one last example and close today's lecture. So our last example for today is, let F is, it's defined as ordered pair x comma x square divided by 1 plus x square. So this is one ordered pair x, and the second element of ordered pair is x square by 1 by x square, such that x belongs to the set of real numbers. So this is a function. From R to R. So find the range of f. So we are given a function and we are asked to find its range. So the range is this set of values that this can output this. So the first element is the set of values that x can take, and this second element is the set of values that we get at output when we put different values of x. So here x square is always positive. So for any real number x, this x square would be positive, and this 1 plus x square would also be positive, more than 1. So we have one number. Say if x is minus 5, then we get 25 divided by 26. If we take even any positive or negative real number, we will always, the numerator is 1 less than denominator. So denominator is always 1 more than numerator. So this value is always less than 1. So it can never become 1. If x is 0, it will become 0. And if if x is 0, then it's 1. If x is 1, then it's 1 by 2 or 0.5. So somewhere here. If x is 2, then somewhere here. So this function will be like this. It will go close towards 0 at infinity. So at 0, if x is 0, then it's 0. If x is 1, then it's 1 by 2. So it's 0.5. If x is 2, it's 4 upon 5. It's 0.8. So at infinity, it will be infinity by infinity plus 1. So close to 1. So it will be like this. If this is 1. And similarly for negative. So it will approach towards 1 but will never reach 1. At infinity, it will be infinity divided by infinity plus 1. So it will be nearly equal to 1. At 0, it's 0 by 0 plus 1. So it takes values only in this range, 0 to 1, but never equal to 1. So we will denote its range by 0 is included, because at 0 we get exactly 0, but 1 it can never reach. 1 is excluded. It will be 0.9999999, but never 1. So this would be the range of this function. So that's all for this lecture. Thanks for watching.